Here we are looking at similarity, triangle similarity one more time. The idea here is that we're going to be looking at the postulates and theorems. The first postulate that we looked at last time was the angle-angle similarity postulate. And basically, you need to just have two congruent corresponding angles in a triangle, and you can prove the two triangles are similar. Now we're going to add two more theorems. The side-side-side similarity theorem, which will make you have to have a statement of proportionality where the corresponding parts of the triangle are then going to be congruent. The corresponding parts having the exact same ratio, that is. In the side-angle side similarity theorem, you need one angle and then the two sides that are next to the angle. So if we talk about this angle A and angle D, we'll need the sides that are on this, right next to it. So we'll talk about these two sides as well. And that will have a sort of a smaller statement of proportionality where the ratios have to be consistent. So like 2/3 or 5/8 or whatever it might be, just like for the side-side-side similarity theorem. First, we'll look at this example. Is either triangle LMN or RST similar to triangle ABC? This first one, if we look at this is 10, 10, 12. Looks like we have 8, 8, 6. It looks like 6 would be half of 12, but then 8 is not half of 10, so that's not going to work out. We have 10 to 5, 10 to 5, and 12 to 6. This one seems like it's going to be the same because the ratio is going to be the 10 to 5 is going to be consistent with 10 to 5 and then 12 to 6. If we look at the second one, it's actually going to be ML and this triangle here. We have the same ratio, the 8 to 4, the 9 to 4.5, and the 10 to 5 is either a 2 to 1 ratio or a 1 to 2 ratio. Depends on how you look at it. If you talk about this triangle to the second triangle, or from this triangle to the second triangle, is how it will be determined. Determine whether the two triangles are similar. If they are similar, write a similarity statement and then find a scale factor of A to B. So in that case, they'll tell us that we need to have this to be our starting place, this be our ending place. And in the past, where we've written our scale factor has always been sort of the end over the start. They're telling us specifically that they want it to be A over B. So that's a little bit new for what we're working on. Just a little bit different than what we've had in the past, so we got to kind of watch out for that. Okay, so let's get started. It says determine if these are similar. What I like to do is I like to look at the 85 degrees, and I like to compare the consisting parts here. I'm going to look at triangle A to B. So from A, I would have the 3 over the 12. I'm going to say, is that equal to the 4 over 16? Yeah, those simplify down to 1/4. So I'm going to say, yes, these are similar. And then I need to write a similarity statement. So I would say triangle, I probably would name this in alphabetical order just for ease of sake, JKL. I'll say that's similar to, let's see, J was not the 85, but it was down the side that had the 3, so that would be Y. K was the other side, so that's going to be Z, and then I'll end with X, so Y, Z, X. And this order does matter. The first one doesn't, but based on the first one, your second one does matter. For number 4, we'll look at this. We'll again compare A to B, so I'll have a simple fraction A over B. I'll try to set this up. I'll say, let's say, compare 10 over 18. Let's try see if that's equal to 9 over 16. Man, I don't really see a good way of simplifying either one of those fractions, so let's not try that. Let's try it the other way. Let's try 10 over 16. Yeah, we can simplify that a little bit. And then let's try 9 over 18. 9 over 18 simplifies to 1 over 2. This guy simplifies, they're both divisible by 2. That'd be 5/8. You know, either way that I try this, I cannot get this to work out, so I'm going to say these two triangles are not similar. Okay, next, show that the triangles are similar. Okay, so we need to show that they are similar, and then write a similarity statement, explain your reasoning. I'm going to start with number 7. It looks a little bit easier to me. I'm going to compare this 3.5 to the 7, so 3.5 over 7, and we'll compare that to 4 over 8, and that's going to give me a scale factor of 1 over 2. I can also then prove that these two angles are congruent by the vertical angles theorem, because vertical angles are congruent. So by the SAS side angle side angle side, I can say that these two triangles are congruent. So I'll say triangle GKH is similar to, I'm not going to say G and M, I'm going to say N, K, M. Again, G and N are both the sides that have this same ratio, this 4 and this 8. So 8 and the 4, so I have to start with these two letters. Over here, this is a little bit more complicated. If we look at our triangle, probably we're going to be comparing this 5 and this 10. So let me see how I can write this. I'll just say 5 over 10, make sure that I'm going to get the same ratios. If I compare now this side, this 4 side, probably to this entire length right here, and that's kind of complicated. So 4 over 8, that does keep the same ratio. Finally, I'll have to talk about 6, and I'll have to compare that to this entire side, the 4 plus 8, which gives me the 12. That does give me a ratio, again, to 1 to 2 like this. So that's how I'm going to have to do this. Again, that's going to be about a side similarity theorem, that these two triangles are going to be congruent. So let me see if I can write the similarity statement. That'd be triangle PTQ is similar to triangle P. Now PT was the 4, so I need to compare the side that's an 8 in length, so PRS is how I'm going to have to write this. PRS. Okay. Not every single time is this ratio going to be as simple as 1 to 2. It's not just going to be 2 to 1. There's going to be some much harder ratios probably when you're working on your assignments. So watch out for that. I think a really good skill is for you to be able to write similarity statements. Probably most teachers are going to give you the first half, and you just have to write the second half so that you can associate and talk about how the corresponding sides and corresponding angles are related. Okay, I really like these problems, and most teachers do. They're usually called indirect measurement. The idea is that this girl has a mirror on the ground right here, and what she's doing is she's looking straight down in the mirror, and it's hopefully trying to, in the mirror there's a reflection of the very top of the tree. That's what's showing here. She's going to stand straight up, and she's not going to move her head down. Only her eyes will look down at the mirror. So she's hopefully standing at a 90-degree angle, and hopefully this tree is standing at a 90-degree angle. At that point, because this is a mirror, these two angles are going to be congruent, and because they're both standing tall, I guess here, this is 90-degree angle, that's a 90-degree angle, we can prove these two triangles are similar by the angle-angle similarity postulate, which we talked about in another section. At that point, I want to set up a quick ratio. This would be for number 15. And what I do for this is I talk about two different objects. The first object I'm going to say is this student here, the student, and the second object is going to be the tree. And then I want to talk about two characteristics for each of them. So I'll talk about the height of one, and maybe like the distance from the mirror is my other characteristic. Now you could have set this up differently. You could have said tree over student. You could have said distance and height. Just mix those around. And whichever way you do this, you're still going to get the same ratio as we go along. So the height of the student is 6 feet. The height of the tree is h. We don't know that. The distance from the student to the mirror is 3 feet. And the distance from the tree to the mirror is 11 feet. I'll simply cross multiply. That'll give me 66 equals 3h. When I divide both sides by 3, I'll get 22 feet for the height of the tree. Next, it says another student who wants to see the top of the tree. The student is 5.5 feet tall. If the mirrors remain 3 feet from the student's feet, how far will the base of the tree have to be from the mirror? So we'll use the same sort of ratios. This student is now 5.5 feet tall. And the height of the tree now is known as now 22 feet. And that's going to have to be equal to the distance from the mirror is still going to remain this, but we're going to have to figure out how far is the tree, how far is this distance going to be if we start moving things around. We cross multiply, we have 66 equals 5.5x. When we divide by 5.5, we should get a total of 12 feet exactly for us. So in this case, this changes. We'll look at one more problem really quickly. Again, we're going to be using the angle-angle similarity postulate. One thing I just want to point out is that this is 72 inches, and this measurement's in feet, and this measurement's in feet. So keep that in mind as you're working on this. A second thing, if you have a building like this, if you have a building and it casts a shadow, remember, even though the way it's drawn a little bit differently, the shadow is technically 24 feet long. And that'll lend to some interesting answers if you don't keep in mind the 72 inches in feet to make sure that they're always in the same units, and then make sure that this is a total of 24 feet. We looked at these two theorems, the similarity theorems. One was side, 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 one was side, angle, side. Hopefully through this you've been able to glean a more better understanding of the similarity theorems and how they are used with triangles.